So now we are going to discuss about problem solving with computer. This is first chapter in this series. So basically, on problem solving with computer, we have break down the major topic, that is problem solving with computer, into 7 subtopics. They are problem analysis, then after designing algorithms and flowchart, then after coding and compilation and the execution of the code. Then after we'll discuss a little bit about the history of C. We'll move more to the C after the fourth subsection, and then we'll discuss about the structure of C program. And the sixth we'll discuss about debugging, testing, and documentation. And in last section we'll discuss about the different elements of C. So in this first section, let us introduce the introduction and problem statement of problem solving with computer. So basically, let us assume there are numbers of problems in our daily life, and let us think, or let us remember how we solve those problems. Something like we have a problem, we think about that, and we think about different approaches and that are available to solve the problem, and then we go to execution. We never go to the execution as of now, or as far as I remember. We never go to the direct execution unless it is emergency kind of condition. Before that, we'll think about that, and then we'll divide that problem, and then we'll solve, or we'll provide the solution step by step. Something like that. Suppose we have to calculate the simple interest. So what things we need? Something like we need principal, we need time, we need rate, and then we'll go through. After that, we'll calculate we need a formula. Then after we'll calculate the simple interest. Yes, something like that. The problem has to be divided into smaller chunks, smaller parts, and then only we can solve the problem. And we have to we need a clear idea, clear picture of the problem. Then after we can generate the solution. Next one is, suppose we have to prepare a mark sheet. Yes, on every problem we have to be clear what is the problem, what are the inputs required, and what things need to be processed, and what is the expected outcome. We have to ensure those things. We have to stick on those things, and then only we can generate the solution, either doing manually with paper and pencil, or with the help of the programs or any softwares. The main mechanism, the essence is the same. And here we are going to solve the problem with the help of computer. So computer is generally a dumb machine. I think it doesn't have intelligence unless it is AI enabled, or it has advanced features. Basically, it is let us assume it is a dumb machine, and it cannot do anything alone without software. That is, it needs software. Without software, the computer, the hardware, can't do anything. So any computer needs the program to execute, or any softwares to execute the activities or different programs. So software is a set of programs written to solve a particular problem. Yes. So softwares are generally designed to solve or to make something easier. And that is a set of programs, and a software is a combined form, or it is a package of the programs. And software is a set of instructions on the basis of which computer gives output or a result. It takes input, and then on the basis of the input, it processes that, and then it provides the output to the individual. If the instructions are correct, it produces expected results. If instructions are wrong, then computer always gives wrong result. There is no chance of having or producing the right result. If you provide the wrong result, wrong input. So what we have to remember is just writing a code is not sufficient to solve any problem, and so that code should solve the problem. The code is not the solution, but the result that code produces is what we need at the end of the coding, or at the end of the programming. And program must be planned before coding in any computer language available. Without planning we can't go directly coding, and we can't program. If we go like that, then we'll have lots of trouble, and we will lose our nights debugging on the debugging codes on long run. But at the start, what do you think is why we need to plan? Well, I know I can do. Yes, we can have it at first. We can have such kind of confidence, and if we can go directly on writing coding and directly write the programs, then we can. At that time we can. But we at that time we may lose, or we may lift something that are very important, and we may not handle the some important parts. So that may occur. That kind of problem occur if we directly go and write programs. But if we properly planned and then we go to the coding, then there is a less chance of missing those things, and we'll have a better programming and better coding, and the time of coding will be lesser. And there we can see the result of planning before going to directly coding or jumping to the directly programming. And there may be many activities to be done before and after writing code. Before writing code, we have already knew that before writing code we'll have a problem analysis, the requirement analysis, design, and then after algorithm design, flowchart design, or before that pseudo code or prototyping kind of things. And then after writing code, and we have to test that. We have to if the problem arises, we have to debug that, and then later we have to document that. And there are many activities. Okay, so basically the steps that involve in problem solving using computer are problem analysis. First one is problem analysis. Second one is algorithm development. Then after algorithm development and flowcharting are similar kind of things. The representation are different. The flowchart is a diagrammatic representation of algorithm, and algorithm is a sequence of steps that takes some inputs and that produces certain results, and that terminates the term is the main program. And at the end of the execution of the algorithm, that should produce some kind of the result, and that should be finite. And then after next step is coding. Then after coding, that has to be, the code has to be compiled and execute, and after the executing, we have to debug and test the code. And then after last step is documentation. And so I think I have made the diagram here, and these are the series of steps we have to follow while solving the problems using computer. And in next video we'll go through the problem analysis, and we'll discuss different kind of strategies used in the problem analysis on that video. Until then, bye bye, stay safe, see you in next video.